It's the 4th of October. I'm Arthur Falls, and this is not investment advice. Codius is an open-source smart contract suite under development at Ripple Labs. Although born from an effort to expand the functionality of the Ripple protocol, it stands on its own and is aimed at bringing the general capabilities of smart contracts to all crypto ledgers and beyond. Stefan Thomas and Evan Schwartz, co-authors of the Codius white paper, sat down with me to discuss smart contracts, their capabilities, and Codius itself. Stefan, could you explain how you became involved with Bitcoin, Ripple, and ultimately Codius?
So I got to be involved with Bitcoin back in mid-2010, and probably the two projects I'm best known for are We Use Coins, which is kind of an introductory video that kind of explains Bitcoin, and then Bitcoin.js, which is used by BitPay and other companies in order to Bitcoin calculations in JavaScript. Based on my work in Bitcoin.js, I got hired by Ripple Labs, and I'm currently CTO.
And what about yourself, Evan?
Sure. So I've been working at Ripple Labs for the past year and change. I've worked on a couple different projects ranging from Ripple Charts to Ripple REST, and then joined the Codius project a couple months ago, and then have been working exclusively on that ever since we put out the white paper.
Could you guys give a quick overview of what a smart contract is and what it can be used for?
Okay. So kind of the very origin of it, and you can see the quote in the white paper, we took our inspiration from Nick Szabo, who has been writing about this as early as '96. And he was kind of envisioning just any kind of apparatus that allows you to transact with it in an automated fashion. And specifically, he was thinking about it in terms of coming up with cryptographic protocols that would enforce certain rules of those interactions. And one thing that happened after the release of Bitcoin is that people kind of expanded the idea and thought of it more as you have a distributed platform that's running any arbitrary rules. Within Bitcoin, they would be encoded as Bitcoin scripts, and then you could encode any kind of relationships that way.
And so that can be used for the classic example of a car that knows its owner.
Exactly, yeah, for example. Or even simpler, you can have something like an escrow contract where we want to transact, but we don't mutually trust each other. So we have to hand off some sort of collateral to a third party, and we'd like that to be something that is very impartial and very neutral. So what better than a computer? If you wanna talk about the future of smart contracts, eventually escrow is something that just doesn't scale. Because if you imagine you're entering into contracts all the time over all kinds of things, and the potential damages could be much larger than the amount transacted, and you don't necessarily want to put up dedicated collateral for every single one of those instances. So if this is going to become practical, there's a lot of work that has to be done in terms of finding ways that you don't have to lock up money specifically for one contract. And maybe later in the podcast we can get into some of those ways.
Let's move on and look at the idea of an oracle, and then furthermore the concept of a smart oracle, which or contract host, which you guys mentioned in your white paper.
Sure. So the idea of oracles has been around for a while and is mentioned prominently in writings about Bitcoin smart contracts. The idea is basically that because Bitcoin is deterministic, in order to have any information introduced from the outside, you need some kind of trusted entity that will introduce digital signatures into Bitcoin blockchain based on whether something in the outside world happened or didn't happen. And most protocols for smart contracts rely on these types of entities to give information about, were the goods delivered, did the Giants win the World Series, etc. And the realization that we had was basically, if you're going to rely on these outside entities to provide information which determines the outcome of the contract, then in some ways you might as well have those same entities run the actual code of the contract, because you're relying on them as part of your, you have to trust them to provide accurate information, because providing incorrect information is the same thing as not executing the contract at all and running some different code. So if you can build up a system where you have enough redundancy in the oracles that are providing information or running the code, then you can achieve very high security guarantees, while also this enables you to build the smart contract outside of these deterministic systems like Bitcoin.
It's just something that, based on looking at a lot of different contracts use cases, the Oracle always played a very critical role, especially when you get into some of the more advanced things, like where you're looking at, like one thing that I looked at was crop insurance, or some certain types of futures contracts where you're relying on exchange rates. A lot of those things, the things that happen in the real world play a very, very big role in terms of deciding the outcome of the contract. And so we decided that it just makes a lot more sense in order to tie these different systems together and not add too many components, to have one system that deals with the behaviors and the complexities of the real world, and then ledgers are used for what they're best at, which is coming to consensus and agreeing on a specific state.
So essentially what you're thinking about is compartmentalizing the smart contract functionality away from, or separately to the ledger system like Bitcoin and other blockchain-based consensus systems.
Yeah, the way that we look at it is, in standard software architecture, you have three components. You have your user interface layer. Behind that, you have some kind of business logic or application layer. And behind that, you have a database. And the way we see it is that Bitcoin and Ripple and all of these distributed consensus networks are essentially databases for storing assets and storing different types of information in a global state. And there are lots of wallets out there that are basically the user interface on top of that. But what's missing is that application layer. And the other solutions that have been talked about have primarily been either the application layer is purely centralized, or it's built directly into the database. But we like that kind of standard architecture and think it provides a lot. It provides more flexibility and also is very powerful, because that means that your application layer can interface with different databases at the same time.
Yeah, of course, it's interoperable with all digital currencies, isn't it? Because all you're exchanging is cryptographic signatures and keys.
Yep, exactly.
I think one of the things that has sort of happened in the cryptocurrency community that we think is something that we should work to reverse is that everyone sort of built their own ledger, and now everyone's promoting their thing, and you know, is not going to be able to adopt any technology that anyone else is building. And so with Codius, we specifically wanted to design a system that, you know, it's purely open source. There's no currency built in. There's nothing particularly Ripple-ish about it. It's just something that can tie these different ledgers together in order to make transactions across them more feasible.
Now, I'd like to look at the security model, but before we go into that, what's the relationship with Ripple? So you guys have both been hired by Ripple Labs to develop this platform. Was that after the conception of Codius?
No. So I just for background, I got hired at Ripple Labs back in 2012 to create Ripple Trade, or what was called Ripple Client back then. Since then, I've sort of taken over the position of CTO, and I'm kind of working on general architecture and strategic initiatives and that kind of thing. Within Ripple, the reason for building Codius was just that we had internal use cases. Most notably, we had a lot of people who were building wallet applications and credit card applications on top of Ripple, who needed to do things like pull money out of a Ripple account without that user being online or being logged into their Ripple account. And so that created sort of a need for us to have a business logic layer for Ripple. And originally we tried to build it into the network back in early 2013. We came up with something which was basically a Turing-complete deterministic interpreter built into Ripple. And what we pretty quickly realized is that the engineering complexity of that kind of system grows very quickly, and we noticed that it wasn't going to be a very stable architecture because of that. And that's where kind of this rethinking came in. And I think a lot of people have been thinking along similar lines. Like, for example, Gavin actually posted before we did about this very idea, which we now call smart oracles, he called it Bithereum, where he said that you can do the same things that Ethereum can do on Bitcoin if you just have oracles that have a little bit more advanced functionality and a little bit more advanced programming languages built in.
That's it's interesting you mention pool payments, because that's something that crypto finance so far hasn't seen a means of implementing, is a way for a service provider to automatically pull, say, subscription fees from a subscriber to their service.
Yeah, so that's actually something that I'm working on at the moment, and an early prototype of that will be released soon. But the idea is that this wallet contract will have control over your money, and this could be in basically any cryptocurrency that supports multi-sig or threshold signatures. And you would be able to encode any...
We should maybe explain those terms. So
sure.
Yes, definitely.
Multi-signatures is the kind of way that Bitcoin does it, where you have multiple public keys that are associated with a Bitcoin address, and then some number of them are required to sign. Bitcoin allows you to have different thresholds and different numbers of keys, up to, I believe, 7 out of 11. And that gives you some flexibility in terms of having multiple parties instead of a single trusted party. And then threshold signatures are basically a technique that is possible with some other signature schemes. It is possible with the one that Bitcoin uses, but it's a little bit more difficult and has constraints. But there are signature systems that allow for it very conveniently. So, for example, Schnorr signatures. And if you use a signature scheme like that, several cryptocurrencies do, such as NXT, Stellar. And so we can use that signature system in order to create a single combined signature, which to the network looks like a standard single signer signature, but is actually a multi-signature that is composed out of maybe 10 signers, 100 signers. You really don't know, and so that allows us to hide all that complexity from the network. So it's in our opinion, very elegant solution, and we're looking to add a crypto system that supports this to Ripple in the near future as well.
Something that makes me think of is code obfuscation. Is there any way to hide the inner workings of a contract from the smart oracle or contract host that might be running it?
So, naively spoken, not necessarily, or not really. There are some very advanced techniques around homomorphic encryption that might become available someday. But as things stand right now, you're going to have to give the host the code that you want them to execute. But that might be something that in the future we can get around using advanced cryptography.
What's the security model for? Well, I suppose there's not. Yeah, I suppose we can move on to that, because there's not really a security model. It just relies on the integrity of the smart oracle.
So when we talk about these kinds of systems in general, so taking Bitcoin as an example, you're always talking about someone is verifying things, and then some parties are relying on them for that verification. So in Ripple we call it a trust graph. And we can draw a different trust graph for any network that we want. So, for example, in the case of Bitcoin, everyone who's a simple payment verification client, an SPV client, which is kind of like a lightweight client, like your mobile wallet or something like that, they will usually rely on the majority of miners in order to inform them about the state of the network. What that means is you can kind of draw arrows from every single lightweight node that point to that set of miners. There's been a very interesting paper recently from Blockstream called Sidechains, and in that they call that a dynamic membership signature. And based on that term, I think it's a really poignant term, because it's basically like a signature. So what the Bitcoin network does is essentially all the miners are signing something together with work instead of with knowledge, which is what most signatures are. and then the clients rely on that signature in order to determine the truth of the network. And so if you take something like Bitcoin and you think about it in Codius terms, if you have something like threshold signatures, you could potentially create a system where all of the Bitcoin miners are also Codius hosts, and all of them are also participants in a threshold signature that you've set up for one particular use case. And so you can map that security model, if you want, to Codius. So Codius is a generalization of the peer-to-peer security model, where you always have to trust some threshold of parties to do a certain thing. And the only thing that Codius doesn't have right now, but we could certainly work on that in the future, is this dynamic membership piece. So, for example, if you wanted to build something where you have a smart contract that is tied to mining power, then you could have a dynamic membership signature where miners join and leave, and then that signature is what decides the outcome of the contract. So I'm sorry if that gets very technical, but when you're talking about the security model, Codius really leaves it up to the creator of the contract, right? It's completely independent in terms of how fancy or how advanced you want to get with it, and how much security do you need for your use case.
This is a slight digression, but a little bit similar. I was in the white paper. You mentioned the idea of a capability-based language with reference to George Orwell's Newspeak.
Yeah, of course. So a capability-based security model sounds really fancy, but it's actually very simple. A lot of people might be familiar with JavaScript. If you're a developer, it's the language that browsers use to make websites interactive. And when it was originally designed, it was designed for the browser. And so it was designed with certain functionality which was intended to be non-destructive to the user's computer. So you wouldn't want to go to a website and then have that website reformat your hard drive, or like delete your operating system or something like that. And so from the very start of the language, there were certain capabilities which were just not built into the language. Now, to contrast that with another approach to security, Java, for example, has something called a security manager. And the way that works is Java has all these abilities. It can theoretically delete your operating system if you're running it with the right privileges in your operating system. But those features are sort of restricted or turned off based on security policies. So that's like a policy-based security model. The advantage with a capability-based model is it's much harder, or it's much less likely that you'll have bugs in it, because all that needs to happen with a policy-based model is that, you know, you miss some case or you miss some special thing to look for. Whereas with a capability-based model, since the feature isn't in there in the first place, since there's no way to express something like a file system access, that can't happen, and it's very unlikely that there will be a bug that allows you to have file system access. So, and to your other question, like, is that something that Codius currently supports? Yes, one of the sandboxes that we're using is a heavily modified version of Node.js. We're just relying on JavaScript and the V8 engine as a capability-based sandbox. And those who are interested are absolutely welcome to look at the code and kind of dive into what we've done with that.
Back onto Codius. How does it fit into the Ripple ecosystem? How is it being specifically deployed to enable services within Ripple?
Sure. So the idea of this wallet that I'm working on at the moment is that you would be able to store money in it. So you would transfer some money, ideally in either Bitcoin or Ripple or something else entirely. You would transfer money such that only the contract controlled it, and then you'd be able to set the contract up such that it would have different types of rules on it, or that you could customize the rules. So, for example, I could give the New York Times a token that said, this is for the New York Times, they have this public key, they're authorized to draw $10 out of my account per month. And then what the contract would do is when the New York Times submits a request to it, would validate the request against the specific policy that I've set up. And what's cool about this is that you can customize it to do basically anything you wanted. You could implement daily spending limits so that if your account was compromised, the attacker wouldn't be able to withdraw all of your money at once. You could set up policies for monthly spending limits. You could have single-use tokens that you can give other people You can implement a lot of complex functionality on top of this, but in a secure way.
There's one little addition I want to make. We talked earlier in the conversation about how putting up escrow for every single contract that you enter into is not really viable. And similarly, you wouldn't want some contract which holds your money and it has like one piece of functionality, let's say pull payments, but it misses a bunch of other functionalities, such as maybe what's called an authorization hold, which is when you go to a hotel and they put a hold on your card. So you want not really contracts that are use case specific, but rather contracts that fulfill some sort of function. So for example, this would be a wallet contract, and it would contain all sorts of modules that you can add and remove that control specific wallet functionalities, such as password reset if you lose your keys, or spending limits so that if someone takes over your account temporarily, they can't just clean it out, or authorization holds, pull payments, and so on.
So when you say these different modules, you mean different functionality that can be employed by a wallet to serve specific tasks?
So the way that we think about it with Codius right now is that we think that Codius contracts will be able to talk to each other, and one of the things that we want to make really easy is that particular piece of it. And so presumably you'd have some very minimal contract, which might be on the level of this just holds your funds, and then you can add modules to it or remove modules from it. And then there might be a next level contract which has the password reset functionality, for example. And so that's kind of the level of how we're thinking about it. And in the future, I'm sure we're going to develop that architecture further. But for right now, it's really intended to be a pretty simple thing. One big topic for contracts is upgradability. So, as we mentioned, some of these rules can get very complex. So how do you keep them updated? And there might be some form of, developer keys or some rules around when the actual code of the contract can get modified. And then the contract that actually holds the funds might not even contain much of that logic, but rather just be the rules for which contract rules that you're actually using. I'm sorry if this gets very meta, but that's kind of how we think about it.
No, it's good. It's it's the conversation that needs to be had. Otherwise, you'll never understand how these things work. The whole idea of contracts is incredibly meta.
Very true.
You've designed Codius to work in multiple languages, right?
So right now we're focusing on JavaScript, and it was a decision that was actually based on community feedback when we were coming out with the white paper, and people reviewed it. One concern that we heard very often is that you guys are spreading yourselves pretty thin if you're going to support all these different languages and a lot of these languages to do common things like threshold signatures or multi-signatures and so on. And so one thing that we decided to do is focus on one language, and we chose JavaScript because of a number of reasons. One is the fact that it's capability based, so it has a very strong built-in security model. The virtual machines that are out there, they're pretty heavily developed and very well maintained. They're very well reviewed from a security perspective. They are capability based. They are pretty fast. There's very good support for them. And then JavaScript, of course, being the language of the web, since our mission statement here at Ripple is to build the value web, it seemed like a very good fit to use the programming language that is generally associated with the web. So that's why we're focusing on JavaScript. In terms of supporting other languages, I think the highest priority would be we've already done a lot of work into native client, and it probably wouldn't be too much more to get that into a working state. So we'll probably aim to do that, which would give you access to C, C++, and Go. You could implement other interpreted languages on top of that sandbox as we originally envisioned. But based on our practical experience trying to do that with JavaScript, the performance might not be fully native because some of these interpreters use very advanced techniques that are hard to port into that sandbox. So we kind of frame it now as a C, C++, and Go. Other languages where people express a lot of interest are things like Python and Java. What else, Evan?
Ruby to some extent, but it was mostly Python, Java, C and C++.
Right. And so we'd love to provide support for those, but it would probably be in the form of maybe community bounties and or just accepting pull requests for people out there who are interested in adding those languages.
Cool. So it's only just you guys working on it, or do you guys have much community involvement?
So right now within Ripple Labs, we have 3 people working on it full time, and then I'm working on it basically evenings and weekends because I absolutely love Codius. And beyond that, I think as there are more internal use cases, some of the Ripple teams might, do a pull request here and there because they're using it for their various projects. Outside the community, hopefully people will start using it and start contributing back. So hopefully there'll be an open source community that grows around it. And I think that what makes me optimistic about that is just the fact that, again, it's really it works with every cryptocurrency, and so hopefully a lot of people will find it useful. We've already talked to some people from NXT, and they've given us good feedback on it. So hopefully we'll see a lot of uptake.
So who else have you discussed this with? Because it seems like this is a major it's a major piece of infrastructure that can work for every platform and provide this functionality for every platform. Like you said, everyone's working on their own ledger for some reason, and incorporating functionality into those ledgers. But at the same time, this is platform agnostic and brings smart contract functionality to absolutely every currency and ledger out there.
Right. So, I mean, we've given presentations at a few conferences before, but we haven't really, started the outreach too much because there wasn't a usable prototype yet. Now that we're getting closer to that, we thought that it made sense to start reaching out more to the community. There has been some incoming interest from both our banking partners and other businesses who might want to use it for things like corporate treasury and business use cases like that. And our business development team is kind of talking to those. Then there's a number of interesting communities around smart contracts. So there's things like, I think you had some people on the show who are in that same space where it's about art and like representing the ownership of like limited edition art on blockchains and that kind of thing. We've talked to people who are interested in insurance related to blockchains. We've talked to people interested in just revolutionizing the legal industry by applying software development principles. So there's a lot of interesting projects out there, and I think what Bitcoin's really done for this space is wake everyone up and not feel so alone in thinking about these things.
It's interesting you mentioned that, because that's something that Bitcoin really has done, is bring all of these different fields together in such a way that they can learn from each other and develop in unison. I was speaking to someone last week about how there's no requirement that you be a coder or a cryptographer or what have you. Anyone can participate and in the space just by thinking about these things and exploring their relative field in relation to others.
Yeah, and that's actually something that in the very early days, 2010, 2009. Of Bitcoin, that was not necessarily the case. I mean, there was some premonition of that, but a lot of the people in the community were very technical. And I think what's happened over the last couple of years is that has really expanded, as you mentioned.
So using I mean, I was looking at the white paper, and it did say that you'd talked to. Hang on, I'll have a look right now, so I'm not just spouting off names off the top of my head. You'd spoken to Gavin Andreessen and Mike Hearn and some of the guys at Ethereum as well. What was the nature of those guys' input, and kind of how did they influence the project, if at all?
Mm-hmm. So one thing that we got, for example, from Mike Hearn was kind of the idea that he was pushing very hard for using Java. He had a lot of interesting comments about trusted computing and how Codius relates to trusted computing. That might actually be an interesting point to kind of convey. So to a lot of people, when they first look at the white paper and they first read about it, it kind of sounds like Codius is trying to provide a solution for that trusted computing problem. The trusted computing problem is, I give you a piece of code to run, and I don't know if you're going to run it without changing it first, right? And so if you could somehow attest to that, that would be really useful in order for example, banks or hosting companies to provide additional assurance to their customers in terms of what their business rules are and how they're going to enforce them. Now, with something like Codius, yes, you are uploading code, and yes, the host is hashing it and doing all these things, but we're not actually solving the trusted computing problem at all. If there are trusted computing technologies in the future, like for example, we've been talking to Intel. They're working on a project called SGX, Software Guard Extensions, which is basically a new evolution of what the trusted platform module and some of these previous technologies around trusted computing have been trying to do, but on the actual processor core, which was one major limitation of previous approaches, was that you could just put a probe on your motherboard and pretty much mess up the entire security model. It was specifically not designed to protect against hardware attacks. But let's say one of these technologies comes out, and then all that would need to happen is for some Codius host out there to modify the software and start offering that as a service and kind of providing whatever signatures or assurance tokens that these technologies create and attaching them to their contract output. And so it'd be very easy to add that sort of to the Codius ecosystem. So I've kind of talked about what Codius doesn't solve. So the question is, what does it solve? Well, if we have someone that we trust, let's say, I'm trying to transact with my friend Rob, and Rob, he's a nice guy, but I don't necessarily trust him to oversee that transaction between us because he's involved in it. He's very partial to it. Let's say it's about selling my car or something like that. However, if we can introduce a third party, it doesn't even have to be distributed. It doesn't even have to be multiple parties. It could be as simple as, Amazon. Now, Amazon probably doesn't care about the particular outcome of our, car sale transaction. And so we can probably trust them to run that code. Now, the issue is with current hosting technologies, if I upload the code, I'm the root account, I'm the owner of that server, and I can mess with it after the fact. There have been some really interesting projects in the Bitcoin community. I think one of them is from someone who even worked at AWS, so they're probably pretty good, of trying to address that problem, but they're kind of hacks. They're kind of like retrofitting something that the API wasn't designed to do. And so with Codius, we wanted to kind of put our foot down and say, like, okay, here's a standard for if you're a hosting company or you're a trusted organization and you want to provide that trust as a service to people, then you can run this software and not have to worry that, the code that people upload will break out. And also people will have the kind of infrastructure and the tooling necessary to verify what code you're running and so on. And now, if I want to transact with Rob can upload the contract, or I can upload the contract, and Amazon will provide automatically a signature saying that, yeah, they are claiming or warranting that they are running that code. And then that, in turn, can become a primitive or like a basis, a foundation for building peer-to-peer applications on top of. So whereas right now, for example, Ripple, if we wanted someone to run a Ripple validator, we'd have to go to them, we'd have to somehow incentivize them, convince them to run the validator. But with Codius, we can essentially just upload it to them, and Codius contracts will have built-in billing so that the host is automatically rewarded for the work that they do.
How does that billing function work?
So the billing function is probably one of the biggest pieces of functionality that is going to be very complex. I mean, it's not going to be I guess, difficult from a theoretical sense, but it's going to be pretty difficult from an engineering sense. The way it's going to work is we're going to use time spent as a proxy for CPU resources. We're going to use memory usage as one of the metrics. And then the final thing is just the number of sys calls or API calls that the contract makes. And each API call that we expose is going to have some sort of cost attached to them based on how expensive it is to the host. Compared to other approaches, like if you look at Ethereum, for example, since they need to have deterministic accounting, they have to do a lot more work in terms of if one host says the contract uses this many resources, every other host has to agree with that. Otherwise, you might get a contract that has a sufficient fee in the eyes of one host and then an insufficient fee in the eyes of another. Whereas with Codius, since there's no built-in consensus network, we don't necessarily have to agree whether a certain invocation of a contract was sufficiently funded or not. It would just run on one contract, it wouldn't run on another contract. And the way that we ultimately come to consensus is by someone collecting the signatures, could be the user, could be anyone, could be one of the hosts, and then submitting the final transaction to a consensus network. And then the consensus network is kind of the entity to which we're outsourcing the work of coming to agreement, which is really hard to do. And that's kind of complexity we want to keep out of the Codius system.
The way we look at it is that running smart contracts is very, very similar to just cloud hosting as it stands right now. The main difference between standard cloud hosting and running a smart contract is that it's not about renting a server, it's about running a very specific piece of code. And so we would imagine that there will be a business model very similar to cloud hosting for smart contracts. And what we're aiming for is you could imagine the cost of running a smart contract as whatever the cost of renting a server for a month is divided by however long the little tiny bit of time it takes to actually execute your code. So the whole point, the goal with this is to set it up so that the billing is very, very easy and is very cost effective for people to run contracts, but at the same time makes for a good business model for the Codius host.
Yeah, one thing that I think your listeners need to understand is that each host will be able to completely decide on their own what kind of payment that they're going to accept. And that initially sounds a little bit strange, as if, if I want to upload my contract to a specific host and they only accept, this really obscure altcoin, am I going to have to go out and buy that? So we think that, there's several technologies out there that can convert money very easily, one being Ripple, but we don't necessarily have to bake that in. So someone who builds a Codius client and someone who builds a Codius host, they can each choose whatever currencies that they prefer, and then use some of these distributed exchanges that are being built to convert between them. And so that means that the hosts can accept whatever currency they want, and again, the user can hold whatever they want as well, Bitcoin or anything. So Ripple first introduced distributed exchange functionality at launch, which was January of 2013. And we're still live with that functionality. So you can use Ripple, you can put funds in from anywhere. If it's a cryptocurrency, with Codius we'll be able to build distributed gateways that don't rely on a single issuer. And then you can use Ripple market makers to convert that into another currency and then take it out on the other side. So right now, Ripple has one bank announced in Germany, which kind of covers the European area, and we have two banks announced in the United States, which cover the United States, the ACH region. And our goal is to expand that into every major payment region with just a small number of banks going forward. And once that network becomes established, and again, that's what we see as our primary role within the cryptocurrency space is enabling that integration with the existing financial system. You'll be able to transact currencies that exist, kind of the classic fiat currencies, against cryptocurrencies very, very easily, and it should be much easier to build things like a Bitcoin exchange and so on. In terms of how do Bitcoin exchanges, how do Bitcoins, how do Dogecoins and other cryptocurrencies come onto the Ripple ledger? Right now, it's just through a centralized exchange, but obviously we'd like to distribute that. One technology that's really interesting in that regard is sidechains. They're kind of formalizing what we've been thinking about for a long time, or what we wanted for a long time, which is kind of moving money from one cryptocurrency chain to another. And they kind of point out that for that to work, both of the chains that are transacting have to kind of understand mutually their proof of work algorithms, or whatever their consensus algorithms are. There's proof of stake and so on. But one thing that you can do as kind of a stopgap measure, they mention it in their appendix called federated pegs, is kind of what we used to call a distributed gateway, which is basically you have some set of hosts, and they're used to convert the currency from one chain and then hold currency in the other chain and vice versa. And so that way they can move money back and forth without relying on a single host. This is like the absolute classical use case for Codius, right? If you talk about something like a federated peg, the first question that someone would have to ask, like if you're the creator of a smaller altcoin, how do I get some of these really big names and trusted parties to participate in my federated peg? So how do I, for example, get the Bitcoin Foundation to run a server for the federated peg for my Stefan coin? That's probably not likely to happen, but if we could get some of these entities to run Codius hosts, what that would enable is essentially them becoming federated pegs for any pair of networks that wants to connect to each other. So they wouldn't have to get permission. They wouldn't have to go to Bitcoin Foundation. They would just upload their contract, and the Bitcoin Foundation would be able to run it. And ditto for other trusted organizations in the space. So that's really what we'd love to see, is that it becomes this general service where if I come up with a cool peer-to-peer protocol or some cool multi-party protocol, I don't have to worry about going around and advocating for people to run it. I can just pay for that and set it up and see it running as a distributed protocol right away, and then make my own experiences with it and potentially even do that before I officially announce it. Kind of going back to this whole graph idea. So if you wanted to model Bitcoin's current security, and I know there's a lot of people who are talking about this, well, there's a certain number of mining pools, and if they sign a transaction in a certain way, that means that that becomes the canonical ordering of transactions. So, for example, right now I think it's like 3 pools that have a majority together, and depending on which ordering that they propose, it will be likely that ordering. So any distributed system is going to have some finite number of nodes that are part of that quorum, and it can be weighted, it can be a lot of nodes, but ultimately there's going to be some number of nodes that are validating. And as you're increasing that number, what that means is that the price for an individual transaction will go up in some form or another, and the reason for that is simply that if you have one transaction that's going to be validated by, let's say, 60,000 nodes, then the cost for that transaction will be at least 60,000 times the cost of verifying it on one computer. That might still be negligible, of course, at some point in the future, but that's just the economics of it. And so we think that for different use cases, there will be different security requirements and then different models that people want to pursue. So, for example, if you wanted to have something where proof of work works really well, then you could choose a set of Codius hosts, and rather than tying into a cryptographic signature, you could tie it to a dynamic membership signature, like what the sidechain guys are talking about. And so, as cryptocurrencies like Bitcoin start to support that type of signature, that is absolutely something that you could do with Codius hosts if Codius hosts started mining. As an alternative, like if you wanted to just identify Codius hosts that aren't mining, and you're just trying to identify parties that you think are unlikely to collude, which is kind of the security model that we use with Ripple, you would just point them out and you would just say, okay, I want these hosts to run my contract, and we think that that is the security that I need for my particular use case.
Yeah, and the point that Stefan made about not colluding is important, because if you picked 5 hosts of for example, well-known companies, imagine like an Amazon and the Bitcoin Foundation and some bank in China or Latin America or wherever, the important point is not that you're not trusting each of the individual ones, you're just trusting that the group of them will not come together to screw you over individually. And if you were to pick a reasonable set of large institutions whose entire business model is based on people trusting them to run code, you have a pretty good guarantee that they will not come together to, going back to Stefan's example, to mess with a transaction that has to do with him selling his car. Like it's not worth it for this group, or you could even blow it up even more, where in certain cases, if you picked a really disparate set of hosts, you would need effectively international diplomacy to happen before the group of hosts come together just to mess with one transaction.
One way to maybe understand this a little better is if you think of hash functions, right? So it's perfectly viable for somebody to completely guess the pre-image for a hash function and break the security of, say, a cryptographic signature. But one trick that cryptographers use is that they just increase the size of the hash so that it becomes a really, really large number, and the chance of just guessing becomes so small as to be impractical. In a similar vein, if you're really, really concerned about security, you can increase the number of validators to the point of them colluding becomes so infinitesimally unlikely that it's not going to happen. And again, that's kind of the model that cryptocurrencies use as well. Again, with Bitcoin, you're trusting 3 out of n nodes. If you have a cryptocurrency that maybe solves the mining decentralization problem a little better, it might be something like 100 out of 200, or it might be something like 500 out of 1,000 or something like that. But ultimately, that's kind of what you're reliant on.
It's a pretty laboured point, I guess, because, like you said, just select parties that are unlikely to collude, and you don't need the, you don't need this massive, inefficient decentralization.
I want to kind of stay on this point one more time because, again, this is something that really, really comes up a lot, and people think of it as, there's one the centralized model on one side and the decentralized model on the other. But again, you are talking about sets of nodes that are validating. Within Bitcoin, there's some 10,000, 50,000, I don't know what the current number is, of nodes that are running the software. That is your set of nodes. So it's no more decentralized than picking 50,000 nodes to run something, right? The only difference is that you have a different kind of influence or a different kind of mechanism for choosing which nodes to trust. There is no such thing as a trustless network. If those nodes come together and collude against you, you're screwed, right? One of the differences with proof of work is that aside from the collusion possibility, there is a takeover possibility. So if I choose 50,000 nodes, then someone can't just spin up another 50,000 with more hashing power to take over. They have to actually get those specific nodes that I picked to collude. Whereas with a choice consensus where you pick the nodes, that's not possible. So it's actually a subset of the problem, and therefore, by definition, more secure. As long as you pick your node correctly. And again, if you wanted to, you could pick them by proof of work. And one of the things, it might sound that I'm not a fan of proof of work or something, and that's absolutely not true. I think what proof of work is really, really good for is the user experience. And people might say, okay, that's not important, but we all know that user experience is the absolute key. So what proof of work gives you, and I think a big part of the success of Bitcoin is that this node selection process is something that it's easy to screw up. It's easy to do poorly. And so what proof of work does is it kind of automates it for you and gives you a list that's probably pretty good and probably pretty sensible because of that assumption that the majority of mining power will be in the hands of honest people, which so far with Bitcoin has absolutely held. That absolutely works. The only issue is that a lot of the partners that we work with, they want to have more control about who they're trusting and to be able to do better risk assessments. And so they want that control, but they're professionals, they're large companies. They can invest the time to choose nodes very carefully before committing to a certain set. And so I think the model that Bitcoin uses works very well for the kinds of use cases that Bitcoin has. And then the kind of model that Ripple, for example, uses works very well for them. And with Codius, we're offering both. So it's really up to you what you want to do.
One thing I would really love to emphasize is just that we're trying to build this such that it'll be really useful across a lot of different systems, and so we would really, really love to get more people from different backgrounds involved with it. And we're coming out shortly with better prototypes and such, and so we would love to get more community involvement from people who do Bitcoin and other cryptocurrencies, as well as use cases from outside. We're really excited both about all the internal stuff that this enables, but we're trying to design this in such a way that it's super useful across the board. So we'd love to get participation from all different sectors.
And if you're interested in getting involved, there is a website you can go to, which is codius.org, codius.org, and hopefully you can put a link in the description. If you go to that right now, we're working on a completely revamped website. But there is a sign-up link for a mailing list where if you want to get updates, such as when the website launches or when we're launching certain prototypes and so on, you can sign up for that and you'll get updates, and we promise we won't spam you.
Thanks for listening, guys. The links are in the notes. Thanks to Cesis for the tunes. Today's magic word is Codius. C-O-D-I-U-S. Codius. You can reach me at beyondbitcoinshow@gmail.com.